Totally agree.
Hi everybody, thanks for joining us here on ACELab 360. For this episode, we're in a little bit of a different place today. We're at Spitz Incorporated in Brandywine, PA. Spitz specializes in making these amazing immersive media domes and projection systems. With us today is Scott Huggins.
Hello.
And so why don't you tell us a little bit about what you do here at Spitz, what you make, and what goes into some of these things.
Sure. I'll start with the room that you're in here. This is a 30-foot diameter Spitz dome. And this would be a representative facility of a school planetarium or a college planetarium. The room that you're in right now is empty of seats because this is a test and development dome for us, so we're regularly moving equipment in and out and moving seats in and out. But this dome would hold about 60 or 70 people if we had an audience in here. Spitz's business really breaks into two parts. We make this dome that you see overhead, and we also make the planetarium display systems like the projector you're looking at right here.
So gone are the days where we just have this big sphere with little holes in it projecting just planets and stars. Now we've got this fully digital system, and there's some things that are special about this. This isn't just like go to Staples and get a projector for your presentation.
Yeah, well
right?
put. 20 years ago, the instrument in the middle of the room would have been what we call an optomechanical star projector. And just like you described, a little point source of light, little holes and lenses in the star ball, and the ability to spin that thing to represent the daily motion of the stars. And that was about it. It was a one-trick pony. Now what you're seeing is a very sophisticated video system. This is a Canon laser illuminated projector. And it's equipped with a custom fisheye lens that we developed with one of our optical partners. And the combination of the laser illuminated projector and the fisheye lens allows us to project full motion, full color, very bright video all across the dome.
And so this is projecting into a 30-foot dome at the moment, but I mean, what would you say is a near maximum size dome for a projector like this?
The biggest dome that we would install this projector in would be about a 40-foot dome. We're looking into 50 foots. Mm-hmm. When we get into larger domes, then what we do is suspend two video projectors on either side of the dome. We hang them just under what we call the dome spring line, which is the bottom edge of the dome. Our most recent installation for one of those big systems was in an 80-foot diameter dome in the south. So we're able to project into domes that are well more than twice as large as this one.
Mm-hmm. And I mean, one that's not familiar with domes might think this, wow, this is really specialized and there must be very few of these things in existence, but it turns out that they're not entirely uncommon, especially in schools and things, right?
No, and in fact, I should tell you just a little bit about the company's history. Our founder, Armand Spitz, established our company in the mid-1940s, and that was back in the days where a visit to the Science Center was not something that you and I would do. We were a very agrarian and industrial country at the time. People just didn't pack up the kids and take them to the local Science Center because it was expensive and time-consuming. Armand's belief was that there should be a planetarium in every small city, in every school, in every college in the United States. And he was very successful doing that. He was able to install planetariums pretty much nationwide. An interesting thing, if you were to take the distribution of planetariums all around the world, it's almost a Gaussian distribution with this building right in the middle. Within 10 miles of us, there are about 20 planetariums in schools and colleges and small museums.
I mean, some of those actually kind of took some advantage of there was a political situation, something called the space race at the time. So it became really, really important for school districts in general to have children learning about science, learning about space. So there were actually government grants that were helping getting these things installed. And
not long after Sputnik was launched, there was an initiative in 1958 called the National Defense Education Initiative, and enormous amounts of money was being released to schools to build technology. And Spitz happened to be perfectly positioned. There were schools all over the United States that had the space to build a planetarium, and in those days, $25,000, which is what a planetarium cost, seemed like a lot of money, but by today's standards, it was peanuts. Someone was able to put in an optomechanical instrument, seating, audio system, dome, everything for around $25,000. So a lot of schools adopted.
So for folks that are creating 360 content, immersive content, a lot of them right now are thinking about making it for headsets, but it turns out that mean, there's quite a few of these domes around, and if they're creating content directed at schools, quite a few school districts at the high school K through 12 level actually have a planetarium somewhere within their school district. You could be creating content directed to a classroom environment, and instead of having kids have to all put on cardboard headsets or anything like that, they could just go to the school planetarium, potentially with a system like this, be able to project it into the dome that they already have.
Yeah, and I should backfill the history lesson a little bit by saying the first digital planetariums were developed around 2002, and within a decade after the creation of these first, what we call digital dome theaters, about 700 of them were installed worldwide, and now the number is something like 1,500. So most communities, most large colleges and cities have a digital dome like this, and that's been great for producers because now there are hundreds of venues around the world that digital content can go into. So we're seeing movies being made for every subject. The planetariums aren't just astronomy theaters anymore. There are movies about mathematics and physics and cell biology and history and life sciences. So it's become a very, very rich environment for production, and there are a lot of films being made now specifically for this format.
And there's other applications besides schools. I mean, that's certainly an area of focus for you, but it's on occasion you've made some for, you know, a few amusement parks that are somewhat well known, and architectural installations as well. So I mean, really, is it fair to say the sky's the limit as to where you could put a dome?
Yeah, I knew you had to go there.
I had to go there, I'm sorry.
But yeah, the story that we tell now about where digital dome theaters are going is that it's a constant broadening and deepening of what we can do with content. The very first theaters that we made where we used video and domes were playback-only theaters. We could literally show movies that were linear and there was no interaction at all. That got modified a little bit to include some audience interactivity. We used to sell seating systems with buttons in them so that people could say, well, I'd like to see the linear show branch in this direction or branch in that direction. Then we evolved into real time where astronomy was everything we did in a planetarium. We could move through the universe, we could land on different planets, we could explore galaxies by taking light years long journeys through space. The next evolution of that was into different topics where we can move in real time. So we now offer a suite of earth science software where we can approach the Earth and fly through its valleys and explore mountains and texture the Earth with different geological information or geographic information or human information or agricultural information. That moved on to the human body and anatomy. So now the realm of what we can see in the planetarium has expanded to almost any subject you can think of.
And developing this, I mean, there are quite a few off-the-shelf tools that you can use anymore. So, you know, whether you're shooting with a 360-degree video camera or, you know, the Unity game engine has that Omnity plugin that, you know, between them, you can then create fully interactive systems that will project into a dome screen, right?
Yeah, the future is beginning to exceed our imagination.
Okay.
Every year, our users visit us. We have a 2-week institute every summer, and we bring all of our operators and all of the scientists and astronomers and physicists who are working in this medium into our facility to share what they're doing. And we now have people who are using small head-mounted 360-degree cameras to do walkthroughs of vacations they took in China. We have people who are using the Unity engine to explore molecules, and we'll have an operator come in and dazzle us with molecules in one of their presentations. And that's why I said the subject area is getting broader, but it's also getting deeper. There are so many new technologies and an ability to sort of take off-the-shelf work and bring it right into the dome quickly.
Excellent. So the domes that you create to project onto, they're something special as well, and you manufacture them right here, right?
We do.
So maybe we can go take a look at how you know, some of the things that go into building these things?
Yes, we will.
All right, so here we are in the heart of the Spitz manufacturing facility, and you're going to take us through some of the different steps that go into making one of these. But before we get too deep into that, first of all, what are the characteristics that go into making a really good projection dome in the first place?
When we're trying to make an immersive experience like a movie or a real-time scene where an audience is looking up in a dome, the goal is for the illusion to be that the dome is not there. Mm-hmm. So we're essentially looking for a perfectly spherical, perfectly smooth, white surface as if you're sitting inside an eggshell. And in order to accomplish that, we have to build up the whole framework of the dome in a couple of pieces. And that piece is essentially, one part of it is the frame or the supporting structure along the back of the dome. And then the other piece of that is the screen, which is that white material that you see that's covering that entire frame.
Okay, and so, I mean, this thing could be 30-foot diameter, 50-foot diameter. I mean, you're making all, this isn't fabric. This is something else.
No, in fact, I'm going to show you a little tiny segment of what would be an entire dome.
We should probably take a step closer so that the camera is able to see that a little well.
So this is essentially made as two components. The surface of the dome, or the skin of the dome, the paneling, is very, very thin sheets of aluminum, 65 thousandths of an inch thick aluminum, and it's very carefully attached to a frame. And the frame is made out of extruded aluminum channel, and these go together like a kit. In fact, off in the distance are stacks and stacks of cases where domes are being sent out to the world, and a requirement for almost every facility is that that case be able to be turned on its side and rolled into a standard doorway. So we have to be able to build this structure that's going to be sometimes 80, 90 feet across, but break it down into little cases that can be rolled into a doorway that you and I would fit through.
Sure. Now, when all of these components are coming together, you know, to get that eggshell look, what happens when the different pieces come together and you've got these seams, right? So.
Yeah, that's about the actual creation process of the panel. Before we get to the panel process, let's quickly talk about the frame.
Sure.
The pieces of aluminum that you're seeing here are raw materials for what's essentially going to be that skeleton of the dome. And those panels that you're talking about are going to be attached to that frame. They can't come in like this, unfinished, 16 feet long. And there's a machine over to the left here, which is a rolling machine. Each of those extruded pieces of aluminum can be rolled through those large rolling wheels, and we can create a perfect radius down to thousandths of an inch, so that the curvature of that frame, that skeleton that's the outside of the dome, is exactly the right shape to accept those panels. So you see next to our rolling machine a set of those aluminum extrusions that are ready to be sent out.
Gotcha.
And those are boxed up, they're sent to a site, they're assembled a bit like an erector set, like a kit, and then we have the skeleton for the entire dome.
So each of these are something that you can custom tailor to each location.
Yeah, and as you can imagine, if a dome diameter is 30 feet, that curvature is going to be much tighter. If it's going to be a 200-foot dome like we have over a casino up in Connecticut, that's going to be a very, very gradual radius. So if you look around the room, you see very, very sharply curved extrusions, and you see much broader curved extrusions as well.
So that's the framework, but then do you just like slap flat aluminum onto that, or there's just got to be more to it?
For that, we've got to go talk about the machines over there.
Okay, all right. So all right. So we started out down that way. We're here now. We talked about the framework. So how does the actual surface of the dome come together?
In order for a dome surface to really conform to that frame, in order for us to get a very, very smooth, uniform surface, we don't just take flat panels and try to bend them or warp them onto the frame. The actual panel itself has to have a spherical curvature as well. And part of the complexity is that it not only has to be curved spherically, the cut or the seam between the panels is also cut along that sphere. So you're dealing with some geometries in 3 dimensions where those panels actually have to be shaped very, very precisely. So that process starts with a die that we create here. If you look along this wall here, we have dozens of dies, and each of them is a 3-dimensional mold that's able to press a panel into a particular curvature. So if we want to make a panel that has the curvature for a 30-foot dome, we pull one of these 30-foot dies off, and then we take an aluminum panel, like you see here, we drop that aluminum panel onto one of those convex dies, and we put it on a machine over here called a stretch press. What the stretch press does is it takes these large panels, these sheets are about 4 by 8 roughly, we clamp those sheets in by their ends, and then this press with the die sitting on it presses up into that panel and actually stretches it out, molds it out into the spherical shape that you see. Once that die has been made into a sphere, we end up with a stack of what you see here, which are these spherically curved panels. Then we make what's called a negative die, and the purpose of this die is we can drop this panel in the convex shape, and then we have a machine over here that we'll look at in a minute that's able to cut all of these arcing seams into the panels so that when they're all cut and they're fitted together properly, it's like puzzle pieces. They actually fit with a tiny, tiny bit of gap in between. And they're essentially seamless. What you end up with is panels sitting so close together that it looks like one uniform surface.
Gotcha. So you make these dies here. You have a set that you've made for your standard size domes, but if necessary, an architecture can come to you and say, this is what we're looking for, and you could create a custom set to press out basically any custom surface.
There are standard dome sizes. Typically there are 24-foot, 30, 40, 50, 60-foot diameters. In European countries or internationally, we're 20 meters, 30 meters, 40 meters. So you'll see that we have dies here that are marked for specific curvatures for specific domes. Occasionally we have a customer come to us and say, because of the constraints of the building, the dome has to be 36.5 feet. In that case, we just make a die. And we have a machine that not only makes the cuts in these panels, that actually does the cutting, but that die will make, that router machine, that cutter will also make these dies as well.
Oh, great. So let's take a look at that. All right. So this is the machine you've been alluding to. Tell us a little bit about this.
This is one of only about 3 of its kind in the world. This is what's called a large bed 5-axis router. And what we're able to do with this router is place really big things on this table and then articulate the routing head so that we can cut anything we want. And when we say cut anything we want, we literally mean making those dies. We take these enormous aluminum blanks and we move the router head over it very slowly and make either the positive or the negative die. We can cut the mounting holes into the frame pieces, which is what these are set up to do, so that when they screw together, all of the mounting holes are already in place. That's all done with this router. And then the most sophisticated thing we do is to lay the large uncut panels on top of the negative dies, and then very, very precisely cut down to a few thousandths of an inch the exact curvatures and the exact shapes of those panels, so that regardless of the geometry we're doing, whether it's an oval or a sphere or a toroid or whatever strange shape of spherical thing we're making, all of those panels fit together perfectly every time.
So each panel is custom for a specific spot in a specific dome.
Exactly.
And everything goes together great.
Exactly.
Excellent. All right, thanks for showing us.
Our pleasure.
Scott, thanks very much for showing us all around, showing us the dome, the manufacturing facility. It's all really amazing. If anyone's interested in finding more about your company, you're on the internet, you have a website.
Yes, if anyone wants to know more about domes, projection systems, or anything else SPITZ does, we're www.spitzinc.com. You can visit us, go to our contact form, and we'll be happy to answer any questions anyone has.
And just out of curiosity, I mean, this is we're about in April of 2017 right now. Are there any conferences that you'll be exhibiting at coming up in the next couple of months?
People can see our technology at the Infocom conference in June. We'll be partnered with Canon there, and we'll have a dome set up. We'll be partnered with Drexel University at the SIGGRAPH conference this year. And then in October of 2017, the National Planetarium Conference, which is being called the Pleiades Conference, is being held in St. Louis. So 3 opportunities to see our stuff this year.
Great. So if you can make it to one of those conferences, be sure to check out SPITZ's demonstrations. And thanks again for watching. Until next time, have fun.
Thanks, Nick.
Thanks.